We will join Chef Debbie and her son TJ in their kitchen once more. After TJ helped his mom calculate the amount of flour and butter she needed for her previous order, she was glad because not only was she able to minimize her resources, she also maximized her profits. Since most companies were rounding up for the year, they needed some snacks for the end of year get-together. So, Chef Debbie got orders for some samosas, chin-chin, and puff-puff from 3 companies. The first company wanted 49, 15, and 5 packs of samosa, chin-chin, and puff-puff respectively. So, she billed them a sum of 12,300 naira. She billed the second company who requested for 20, 31, and 20 packs of samosa, chin-chin, and puff-puff respectively a sum of 9,650 naira. While the last company placed an order for 32, 9, and 14 packs of samosa, chin-chin, and puff-puff respectively and were to pay 8,450 naira. TJ wanted to find out the unit cost of each of these snacks, so he wrote the cost of a samosa as X, the cost of a pack of chin-chin as Y, and Z for a pack of puff-puff. And then he wrote out the equation for the first company, and he had 49X plus 15Y plus 5Z equals 12,300. For the second company, he had 20X plus 31Y plus 20Z equals 9,650. And for the third company, he had 32X plus 9Y plus 14Z equals 8,450. This gives a set of simultaneous equations. Interestingly, these simultaneous equations can be written in matrix form. How, you may ask? The coefficients of the variables form a matrix while the variables form a column matrix, and the numbers on the right-hand side also form another column matrix. Doing this, we have the matrix 49, 15, 5, 20, 31, 20, 32, 9, and 14, which multiplies the column matrix X, Y, and Z. This will be equal to the column matrix 12,300, 9,650, 8,450. You can multiply the matrices on the left-hand side to verify if you will obtain the initial simultaneous equations. We can write these matrices in a compact form as A times X equals S, where A is the matrix of the coefficients, X is the matrix of the variables, while S is the matrix of the numbers on the right-hand side. Now, there are various methods of solving simultaneous equations using matrices, and they include the inverse method, the Cramer's rule, and so on. The inverse method simply involves multiplying both sides by the inverse of A. As we know that A times A inverse gives the identity matrix, therefore X equals A inverse times S. For the Cramer's rule, to get the nth variable, the determinant of A divides the determinant of the matrix formed by replacing the nth column by S. Not to worry, we shall study more about these methods as the lessons progress. But before then, get other simultaneous equations and write them in matrix form.